This is example of Rwanda rainfall data. Now, this is Rwanda rainfall data of 20. You can see here is 2011. This is 2012. This is 2013. This is 2014, and that goes down to 20. You can see here that goes down to 20. You can see down, this is 2021, so you have another one, 2012. So you see this data, then you have another station here repeated on that particular pattern. This one here is the station name. Here now is the station name. Here is the abbreviation. Here is the longitude and latitude. Here is the elevation of that particular sensor or whatever they use in collecting the rainfall data. This is the month on this column. Now each of these months, which is January, February down to 12, and then this is the day, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in that particular pattern. So this is from 1st of that month, and then if you go down to the right here, and then you have 24, that is day 24, and then you go down like that until you have day 31. So anyone that does not have up to 31 are the ones you can see here, like empty or 0. Now this is the summation and this is the average. How did I come up with the summation? The summation I did was I just decided to add from the first to the last, gives you this. What is the average? So you take the average of 30 or 31 days as it exists, so and that's give you the average rainfall every day. Now remember that this station are scattered in different places of Rwanda, so it means that Gutumba station collects this information every day for the whole year, and then the summation, the average rainfall of that particular place is this. So if you look at this data, if you go to Ministry of the ministry that is in charge of rainfall data or sort of things, I can't remember the name again. So they are likely going to give you data that looks like this. In fact, it is even going to look even more bad than that, because they will give you a data that probably might not really look the way you want it to look. So they are not going to give you a clean data. So let me also show you the pattern the data can actually be. Yeah, so if you look here, this is rainfall and temperature data, for example, of Rwanda. Now if you look here, you see now that this is for Kigali city. Now if you also look at this particular Excel sheet, you see now that this is very long, up to 1097. And then if you go back to the heading, you see here that we have, this is Kigali, this is longitude, latitude, elevation, this is the year. So you can see the year here, and then here you see month of each of the month. Here you see day, here you see precipitation. So this data comprises rainfall and then minimum temperature and maximum temperature. So this have both rainfall and then temperature data, as you can see. Now this is also another one. This one have also temperature and rainfall data, and then this one, this is the biggest of it all. So you can see how it is scattered here. So here, this is raw data. Now this is rainfall, then this is where those data are being merged together. So you are likely going to get something that looks like this. So this is what they can give you, assuming you requested for a data of rainfall and precipitation of Rwanda. So this is just what they are going to give you. So it is your responsibility to extract the information you want and how you want to plot it. And then as you can see here, So depending on how you want to analyze it, this can actually be analyzed using geographic contexts, like the way you analyze them by using the ArcGIS or ArcGIS Pro. And this also can be also analyzed using another geography different ways you want. Like for example, this one I showed you now, this is how I decided to analyze it. So you can see this is what I use. We'll be switching soon to the main IDE, and I use the main ID in analyzing them. So you can see this is what that particular data I showed you in Kigali. This is what I analyzed on it. So this is the rainfall of 214. You can see February. So analyze them by month, by the year. So this is 214, and this is the pattern of rainfall of Rwanda in 214. Now this is the pattern of rainfall in Rwanda in 219. This is the pattern of rainfall in Rwanda in 224. So this is the rainfall in 224. Now this is the temperature I'm showing you in maximum and minimum. So this is the minimum, this is the maximum in 2014. This is the maximum and minimum in 2019. This is the maximum and minimum in 2024. So this is how I make the analysis. I did not use ArcGIS, but I decided to analyze it in this particular pattern. And then this is the combination of both of them, combining all the temperature, lowest and minimum. From you can see here, this is 2014 and this is 2014. So you can see the pattern of how the rainfall move over the year. So you see now that when you are talking about the highest temperature in Kigali city, so you are looking at the trend of it coming in this particular pattern. This is the maximum for each of the year. So what I'm saying is, this is well documented. I analyze using Jupyter Lab, and I did not integrate this one to as part of the way I make the analysis on I did not make this analysis on ArcGIS. So depending on how you want to make the analysis, and then what is prevailing or the type of data you collect. But what is important I want to tell you is you can make those analysis on how you want it, and based on how you want to show it. Now if you look here, this is a perfect example of the rainfall data that I analyze. So here I made an extraction of 215, I made an extraction of 219, and I made an extraction of 223. And this is the pattern of the rainfall in Rususa in the, I think, western province, or northern province of Rwanda, around Ngororero. So this is the rainfall pattern of this particular year. So you can see the high, the low, the high, the low. So where you have low are where you have the high, and where you have this are where you have the low. So if you look at the pattern, you see here less rainfall. This is less, high, high, high. So this is the way you can analyze this. This can also be elevation, like I said, because you can have elevation that have X, Y, and Z. So in this pattern, there are several ways you can analyze them, but I just want to give you a practical example. I'm not going to use creating of thin. I'm not going to use converting it to raster like a normal route of creating a contour, or there are different ways of creating a contour in ArcGIS, but I'm not going to pass through those normal route. So first thing, you have this kind of data, you need to transfer this data in such a way that it is readable. Now I'm interested in creating the average per month, and that is the reason why I made addition here. So in this addition, for example, I'm going to insert here. So what I did here in this addition here is that for me to get this number, so I now just go to Excel and do the summation of this number from the beginning here. You can see here from the first day, I'm interested in the first day. So now I press enter, and that is how I come about getting this particular value you see here. So once I have this value here, this is the summation. So you can see now it's the summation of this number. Now what happens again? I can drag it down. So if you drag it down, you see that this number is coinciding with this. But since I'm in Excel, I will just need to double click on this, and this is going to do the rest of them for me. Now this is a way I get this one done here. So you can see this is the average. So the same thing that I want to get, if I want to have the average as what I'm looking at. So I can just decide to still see the same thing here, divide by the 30 or 31 depending on how many days I'm looking at. So if it is by 31 by the month, so you can see the date here. So this value are being gotten here. So if I click on this, and this is going to randomize it, so you can see that this value and this value are the same thing, because this is 2 7. No, something is wrong. This is sorry. So you can do the same thing, and then you make that extraction. So let's see what this one shows us here, over 31. So maybe this is by the year, yeah, but the whole thing is you get the average by dividing it by what is here. So you have the average here. So I don't know why this one is not randomizing, getting this. So over 31. So this is just the way you get the average. So when you have these two average, the same thing. So I made the calculation, and then I removed the calculation. I just copied the same thing and paste. So, and that is how I come about with this. If not, this particular two column are not part of the data was given to me. So I've shown you how the raw data looks. So on this case, I have done this and I've cleaned it the way I want to clean it. So I can now go ahead here, and then I'm just going to save it as. So I will straightly go to the location I want to save it, because I don't want to touch make a kind of distortion on the data. So let me just go somewhere and save it as CSV. So I'm going here, and I'm going to data, and I'm going to say rainfall here. As you can see the rainfall here, so I'm going to save it as here, and that has been saved. So I can copy the directory. So right click and then make copy, and I will return to ArcGIS. So here, like I used to do, I'm going to go ahead here and say save it as, and on saving it as, I'm going to type here rainfall map. But now get the idea of what I said. So I have rainfall map here. Now in here I have under map, layout. So I'm going to switch back to this particular layout, the main layout. Now under here you see I have add data here, and if I click here, that means it will take me directly to the location I want to go. So I can copy this file and paste it, and you can see now that the rainfall data has been added here. You can see here it's added it, and if you open you right click on the table and open it up, you are going to have this something that looks in the attribute table. So what do you have here? So you are going to have this here. So the same data having a feed, 1 feed, 2 feed, 3 feed, 4, all to the feed of this one. As you see here, this is the summation, which is the feed of summation, and here this is the feed this. But there is a problem here. If you look critically here, you see that this have an average and this have this, which is showing you a new feed. So if you go here, so you can see elevation and rest of them. Now this is a way I just added directly. Now if you open up here, you can see add data from path, add xy point, root, and then you can see different way of adding data. So if you go to xy here, now this is going to open for you because you want to add a point. Now the point you want to add here, it is going to read up, and then you should be able to bring in the point data you want to add. So let's give it a bit moment. I don't know why it is a bit wasting time. Yeah, so you can see here, so input the table. Already it have already read the CSV file that we have here, the one we have here, and then this is the output. Then it's asking for x coordinate. Now if you look here, you see now that it started reading on table 8. This is the table 8 it started reading. It ignored this particular one here. It didn't recognize this because of this particular name that is here. So on that case, I'm going to return here to so the Excel refused to work. It's unfortunate that it's the same Excel, the same Excel that I use now refuse to come here. So, but I know that the whole problem with it's simply the data format, and that's where everything is coming from. So there is basically no problem with the file. So it's either I am failing to do the right thing, so that's why I am fighting with it. So there's no problem with, so the problem is me. So there's definitely something I'm not doing right, or there is definitely a format the data ought to be that I'm not putting it, because they used to say that computer is garbage in, garbage out. So it's what you give it that it gives you back. So if you don't follow the rules, maybe I'm not following the rules, and that's why I'm where I am. Now you see now that this particular new Excel file that I save is not existing in there, but this one is there, and it's taking forever to load. Sheet 1. Let me see what the sheet 1 hold. Okay, yeah, so this is what I want. But the problem is I will need to figure out what happened with the data. So currently I'm using the Excel, because if you also look here, you see that this particular one here that I've saved as CSV, the CSV I just saved now is still not working. So but the Excel file is working. So I don't know what happened, but whatever that happened, anyway, it's okay. I will try to check and see what is the problem, but sometimes we used to have this kind of problem, and we'll have this kind of problem, so we still find a way around to solve it. Sometimes I used to now use multiple software to check what is the problem, but definitely it is not the computer fault, it is my fault. There is actually something that I'm not doing right, either the data format, sort of things like that. So something is not normal, and probably I don't have that time to actually checking it one by one. So if it is just like I'm trying to produce maps, so I would have actually go ahead and then relax and now check what is the problem. Okay, so generally this file is supposed to work normal, but it's not working, and then I don't know where the issue is coming from, but you see I worked the way around it, and then this is what I'm able to have here. Now what I was trying to say is that if you see here where I click on add XY point, now this is going to come here. So if you bring it in the way I bring it in here, you can go ahead and select the sheet 1 here, or if you don't bring it in like that, you can still go here to browse for the location. So when you go to the location where you have it, so you should be able to have it here. So if you go to the same location, and then you can import it directly here and select it like this and bring it here. So but since I've already added it through data here, and I have the Excel file here, the first way you can get this done is to go here, which is open up here this data, go to XYZ here, and then you see here that you have longitude and latitude. Now if you need a Z factor, now you need to go to this Z factor, and the Z factor we are looking at now is average. Now if you click on run, and this is going to run the point, and then should be able to give you the Z factor. But remember, the reason why you don't have to use the Z factor here is because if you look critically on the data we are working on, you see now that here is a different Z factor. So assuming you want to go for 2014 here, we are looking at 2014. This is 2011, like I showed them down to here, which is averagely from January to December, and then the same 2012 here. This is January to averagely January to December. Now what it means is that if you want to plot for 2011 and you use all the Z value, which is exactly what I did here, so what it means is that you are going to have the data, but the interpretation here are not the right thing. So you have to select which year range do you want to work on. So now looking at this is Rwanda shape file, and you see now that the data which we are using on is located around here. So you can see the scattered distribution of the rainfall data over here. Now, but if you look critically, see that each of these points here are about, it is more than 2000 plus, as you see here. So this particular data is scattered over this different place. That's repeated because the coordinates are the same thing but over a period of time. Now, in this way, you can choose only to have 2000 and you can choose only to have 2011. And remember here, if you go to the property here, then you see now that we have query definition. Remember what I told us about query definition last time, and I said we can select, this is using SQRL, you can switch it from SQRL and type it as SQRL, or you can switch it here and they select from where you can select only the location, because you want to define this, so you can where, and then you can choose this particular one you want to choose here. So let's say you want to select the deviation or you want to select the summation, so you can use a clause and then say a summation that is equal to a particular this or a year, because we are interested in the year. So you can go ahead, the year that is equal to, you say that is equal to, you can say 2011. Now if you click apply here and click OK, so what happens is that you are only going to have the data that is 2011. So if you look here, you see now that what we have here is the column. No, something is also wrong. So what we have here is supposed to be a column of 2011 only. So in that way, first and foremost, I can decide to export it first to a shapefile because it's event file now. So this is here what I'm trying to say is that you need to know that you are trying to use 2011, because if you go ahead and use the Z component here, which is the summation you want to use here, the chances is high that you are using the wrong thing. So the best thing you can do is to use it by the data which you want. Now in that case, if it is a shape file, this is like a point file here, but you needed to see the pattern of rainfall here. That actually worked, but I don't know how it is working, because you can see the blank of the data, so the ones that are not part of it has been removed from here. Yeah, so but if you remember what I did by query definition last time, you will not equal to 2011. Let me see what happens here, and then okay, yeah, it is working, but I think it is working in its own way that I can't really tell now. So let me remove this. I'm just trying to use it to explain something. Now when you finish up with this, now there are several ways you can go around it, but I'm just going to go to interpolation. Now interpolation, we use interpolation in different ways. We have different types of interpolation method. Now in here, in Arc Toolbox, you go down to spatial analysis tools here, and you can see here you have interpolation. Now interpolation is using what you have, a point you have, to get the other relationship, like other points within it. Like for example, between here that you see this particular data set, and you see that this is 50, and you want to get between here to a point, so you can check using interpolation. So example of what I want to say is that if I draw a line from here to here, now this is 10 miles, and then somewhere here is 10 miles. So because I know that this is origin 0 and this the end of it here is miles, so by here it should be about 5,000 or sort of things like that, or 5 miles, depending on the what I'm trying to use. So if between this place to this place is 10, and I ask where is the middle, this is the middle here, which is 5. So how do I know that this is 5? Because you have told me that the between here to here is 10, so I'm able to use this between line to get the what is in between them. So there is a rainfall here, there is also a rainfall information here, so I can get the rest of information here by making an interpolation. So this is where interpolation works. So in that way, in Arc Toolbox here, so we have these tools here, which is geoprocessing. So you go to interpolation, and there are different types of interpolation and different approach you use them. When you talk about Kriging, Kriging have to do with the ones that have a particular pattern, like a point that have a particular pattern, like you can use them like rainfall, a pattern like geology and rest of them. So there are different ways, or the soil data that have a pattern or this thing. So use Kriging. And then when you have something like rainfall that is continuous, so you can choose to use IDW. Now if you go here, you see I selected this sheet here, and then it is asking me what is the Z factor, because that's what it's looking for. But if you look at the Z factor here, you see now that if you go to average to use average, so it's going to use the average of everything that you have here. So that means it is not just only going to look for this, but it's going to look for average of whatever you have here, meaning that it is going to sum up. And if you want to produce 2011, that means you're not actually producing 2011, because there are average of everything that is here. So in that way, you might need to use different tools like we used last time when we're talking about attribute, to actually select, make a kind of selection. So for example, if you look here, so you have a station name here, or you can use summation. This is, like I said, you can say we are interested in the ones that is 2011, for example, and these are different stations. So we can choose, when after inspecting the attribute table, and then you can choose to select which of them are 2011. So let's click apply, and then let's click OK, and you see now that all these ones, this is 2011, which have been selected around Ngororero. So in this case, if you open attribute table, we should be able to see the ones that are selected. So from here, this is Gutumba, and then these are the ones that are selected. So if you switch here, you should be able to see the ones that are selected here. So these are the ones that are selected that are within this particular area. These are different stations that are within this area. So in that way, you see here selection here, and then you can make layer from the selected feature. So make this layer selectable, make layer from the selected feature. So if you click on this, so you can see that if you open up this attribute information here under selection, so let's go ahead and open up attribute information. So what happens here is that you are only having 2011 on this column. So you see what the only thing you have here is what we have is for 2011. And where is it covering? It's only covering Ngororero, this particular pattern here. So you see this is what you have. So now you are sure that what you want to use is only Ngororero, this particular pattern here, which is 2011, is what you want to produce the rainfall. So in that way, you go ahead, go here and change it to the selection which you want. Then I am using average because that's what I'm interested in. And here, this is the raster output. You can change it to whichever way you want to change it. Now you can decide to leave this one by default. Now when you do it, let me close this and then close this, and then also remove the Rwanda shapefile so this can be visible. So this is a point we are looking at making an interpolation. Now this interpolation we're looking at making, I am going to select Rwanda, and I'm going to just select Ngororero because this is the place of interest based on the data we have. Right click on this, go to selection, then make a layer from the selected feature so that I can only have Ngororero. Remember what I showed you last time, that when you select Ngororero, so it is going to only act on Ngororero, but I just wanted to leave it, separate the rest of them from it. So and that's why I made new selection from it. Now I'm going to go ahead to go here and leave it on default by going here and run this particular one. Remember I've selected it and I've said I need it in average, and then if I run this one, what I'm doing now is that I'm making an interpolation. So that's going to give me a new raster dataset of Ngororero, showing me the pattern of rainfall using the data I've collected. Now if you look here, you see that if I turn off Ngororero, which is this new layer here, and you can see the pattern of rainfall here. using the interpolation. So you can see interpolation, it was able to use between here to here to make this interpolation and show you the pattern of rainfall within this place. But now this is in this pattern, and I'm going to turn on this layer. For the sake of this, I will right click on it and go to symbology. And when I go to symbology, so this is here. I'm going to go to a single color. Remember why it's bringing this, because we are still using the other shape file we were using. And then in the single color here, you can make it hollow. So I want to make it hollow so that it will be visible for us to see it. Now you see here that this is what it turns here to be. Now this is when you're using IDW, which is inverse weight distance. So if you return back here to geoprocessing, so we're using inverse distance weighting. This is the method. Now you see the pattern it shows. Like I said, when we start raster, I'm going to explain this deeper because we're going to use more of it. But I just also want to bring this thing and then still add the Z value as an average, and I'm going to use Kriging this time. And in Kriging, I'm just going to leave everything by default and run it to show you the difference between them and what I was trying to say when you say pattern and when I say continuous. So you might probably understand what I'm saying, but I'm going to explain Kriging very well, and you can see now, see the same particular this thing, so gives us this, as you can see here. So this is what Kriging give us here. So Kriging give us 6, and then the lowest here is 26. So you can see 26 and 6 here, but this one started with 1. Now if you look at both of them, this Kriging is now trying to tell us that this is the pattern the rainfall is in Ngororo. So look at here, this is where it only have a blue dot within around the point. So this is what it is. So I just wanted to show you a bit. That's why I choose to use IDW, because like I said, it is a continuous data. So as it is rainfall, it doesn't form a particular pattern, so I don't have to use that in that way. But now what I want to show you is that if somebody give you this data that is moved around Ngororo and tell you that I need to produce this map, and you produce this kind of map, that means there is a problem. So what happens to this other part? So in this part, that's what I want to show you here. So you go to geoprocessing tools here. When you want to do the geoprocessing, select IDW, then you now input the value you want to go in the point features. Now under the Z value, which is what you have, select the average, and when the average comes, now switch to environment here. Now these are places you are going to explore to actually get it done here. Now you have the output coordinates, you can probably leave it, but when it says processing extent here, default, I can choose to say I want it to be processed using Ngororero here. This is the pattern here. Now data analysis, raster analysis, the raster analysis input maximum. So this is the input maximum, convert it here, but here you have mask. Then I want it to be masked using Ngororero. Then if you have something to snap it, you snap it with. If not, you can leave it that way. So now I went to the environment, and now let's now run and see the difference between what we had earlier and what we have now, to see whether there is any difference between them. Now this environment is important sometimes, because you are now defining the extent of which it is going to go. And then unfortunately we are having almost the same thing. So let me see what is wrong. Yeah, so ideally this particular thing I did here supposed to actually snap it to have it exactly with the extent, the raster analysis supposed to have it with the same pattern as processing extent, supposed to be the same pattern as this particular shapefile that we put in here, and it's supposed to snap on that room, on that particular pattern. Yeah, such that I can have the same output with the shape that I have here. I think I will need to add more data so that I can get the extent of this. So in that way, let me add more data and check what is wrong. But what I'm trying to say is that if you have a raster and you needed to put up the extent, so you have the shape file you want to, this is what I want. Yeah, I don't know what happened in the first place, the first time, but what I wanted to show you is this. So the first one you have here shows you this pattern. The second one is what you have now. So you look at this here, and this is the first one you have here, and it is now not showing you this part of this. But now I want it to be processed to the extent of Ngororero, and this is exactly what I have now as the right thing. So if you look here, you see here that this is the pattern of the rainfall in Ngororero. So these have higher, lower, depending on this you are seeing here. These have high and these have lower pattern of rainfall. So you can see now it following the pattern of Ngororero. And under raster layer here, you can now make it looks better than what it is. So in this is bilinear, so this is, you can change it to this particular, this is a layer here which is called different resampling type. So you can see here, this is very important, because when you are trying to display your raster and then somebody asks you to do a kind of this, and this uses 4 by 4, so this is 4. This part uses 4 by cell. Here you can see it uses the 4 neighborhood, or this 4 by 4. This is resampling method, assign values of the closest cell. Now this is bilinear, which interprets from the surrounding 4 cell that is around it. So this is the first one, so you can look at the color, but this one interpolates values from 16 surrounding around it. So if you are to produce a map that look good and visual, so this is very important, because you are dealing with raster. So when I ask you produce the rainfall pattern of Ngororero, for example, and then you are producing this here like this, so you need to see that there is a problem here, so it makes it looks better. So you see this now, and this is what defines purely the pattern of rainfall around Ngororero, as you can see here. So this is the pattern that looks better, because it uses 16 neighborhood now to show you how it shows. So ideally, this is what the rainfall pattern of Ngororero looks like. So this is not just only as related to rainfall. Like I said, elevation and rest of them. Like assuming you want to represent this using contour, using a contour format or contour method, so you can also still use that. I will come to that later, but I'm just trying to explain something. Contour have to do with elevation, have to do with 3D. So when it have to do with 3D, you should understand what I'm saying. So this pattern is, so I'm just going to say that the interval, I'm going to make it 1, yeah, because this is 1 to 26. So this is just like a pattern. I'm just trying to explain something. Yeah, I'm just trying to explain something. What I'm trying to explain is that this same thing you did can also be done using a contour pattern, like what you see here. Now, this is a contour. If I choose to represent it with this rainfall pattern using a contour, and I can do this same thing I just did here now. And then if I want to label it on it, I can go ahead and label the rainfall using the contour intervals. So if you look the contour here, go to attribute information, so it have also picked this information here, and that's why it is using this particular pattern. This is 26. So if you go to labeling, and you should be able to choose which of the class that is best suiting for it. For me, the best class is ID, not ID but contour. So you can see the pattern of the rainfall here. So by using contour or overlaying with this, you can actually say that the rainfall is higher in this part than this particular place. So you can see here that I'm trying to use contour to represent the rainfall pattern. And also, if you look at the rainfall here, the body, like this particular thing here, if you look at the body here, you see now that it tried to curve it based on the body that we have here. So this is generally, and this rainfall pattern, as we did last time when we are talking about grouping by classifying, so you can see here that I can say that I need it to be only 5 pattern, for example, and I should be able to make the rainfall show me in 5 different patterns. So you can see here this is the pattern it shows, and you can make your changes on the color of your choice here by selecting where it is high or low. For example, here that you want to see it high or low, so you can make it like this, and we can see this is the pattern of rainfall in Ngorororo, classifying them into 5 different patterns. So this you can choose whichever way you want it to be, and then you can see it showing you in this pattern. And remember, the last time we explored all this particular feed, but you see it is changing now because of the information we have. So you see that one, we did not have shaded relief, and shaded relief tends to use elevation to show you the pattern which the rainfall or the whatever you are displaying is showing. So if you look here, you can see now that this is a shaded relief, and then it is trying to show you how using a shaded pattern to show you the difference, using a hill shade to show you the difference how it shows. So this is multi-dimensional, which is going to show you this particular pattern in multi-dimensional, and then multi-directional. Then this is scaling. You can choose to adjust whichever way you want. You can adjust the scaling and then make it whichever way you want, and Z factor can also, depending on how you want to make it. So this is just trying to show you the pattern of the rainfall using the Z value. So this is just using the relief method. I bring it because it was not in the other one when we're trying to explore it, but that can come in depending on the type of data you're using. So you can see here, this is the pattern of the rainfall here in Ngororero, as you can see. So you can now make it the way you want it. So generally, when you have a rainfall, you have an XY. You should be able to get this done like this. So this is 2011, and then if I'm interested in 2012, I can also do the same thing. So you still need to go down to the same table and then do the same thing we did using probably here, still used by attribute. And if I want to make for this is 2011, and I can also make for 2020 here, this is a pattern 220, then I can apply, and then that's select me for 220. Where is the location again? So I can go to this particular table here, and when you open it, what do you see? You see that this is for 2020. So let me click OK. If you look here, you see this is for 2020 here. So let me scroll down to this way, and then here, so this is 2011. But if you look here, you see that it have selected another part, and the one is selected here is 2020. Now in this table, let me turn off this, and let me also turn off the contour and the contour. Okay, and then if you turn on this, you can see where it's selected. So you can see this have selected this within this pattern. Now if you turn on the Rwanda administrative too, you see now that this have exceeded beyond Ngororero. This have also joined different other part here. Now there is something I want you to also know. If you have this point here, and let's say that I ask you, for example, to produce the rainfall pattern around here, so and you have data that is extended beyond Ngororero, so it will be better for you to add all these data together and then clip it off later. The reason is because the more points you have, the more detailed information you are going to have. Like as you can see here, this is Ngororero here, and you have another data. If you only focusing on Ngororero, you only have this, but if you have another point here, you should be able to determine better what happened around here or between here. So as you can see here, the 220 one extended beyond Ngororero. So that means this data can actually be worked in beyond here, and then you get a more and better information. So generally, this is the way you can make interpolation. So you see the same thing we did here. So I can go ahead and go to selection if I just need only this one. But remember what I said, even though that I need to use it, the moment I select this one, the inside this data, the ArcGIS Pro recognize that what you are focusing on is this. So even if I don't want to create a new layer, I can still go ahead to go to geoprocessing, since I have selected this, and I will go to geoprocessing, and you see that return back here. Let's step back a bit, go down to IDW, and then change this to this. You see now this is selected, so I don't need to probably create it as a new layer. For the fact that I've selected it, then it automatically recognizes that this is where my focus is. Then you can see here I can also go to the environment, and then what is the processing extent. I'm going to select the Rwanda administrative level 2, then by specifying that level 2 here, so I'm focusing on this level 2, minimum set, maximum I want you to max it by administrative level 2. Then so let's just hope what we have works as well. So when you go ahead and then process it using this, so you are going to only have this for 2020. Remember what I said, that since you select this, so it is only going to act based on what you have here. So you can see the difference between the Rwanda shape file of 2011 and 2022. So on this case, so we can go ahead to select this. So this is being off, and you can see here this is for 2020. Now this is 2011 here. Then probably we need to also make classification as well. We can go to symbology. So let me just show you a bit comparison between them. So if I classify it, can decide to classify it into 5 pattern, and then let's leave it on the 9 that it is on default. And then I don't know whether I can still find the color that we use on the other one, but whatever color it is, let's still put it because we can still see the pattern. So we can put it on this particular color pattern. Now remember what I explained to you. So on that, I'm going to close up this. Now this is this one. You can see the way this one is. I can select it and go to raster layer, and then if I want to resample it, I can put it in this pattern to make it look better. Now we have this, we have that. So if you turn off this, and then if you turn on this, so this one is here, and then this one is also here. So you have 2 of these over it. This is the latest one, and this is the old one. So this is the pattern of rainfall. Now remember what I said about transparency in our last session. So you can see the transparency between them here. So you can see the pattern. Now let's use swipe. Now let's go here. So if you look here, you see now that the pattern has changed here. So it's not the same thing. So this is not the same pattern with this one. So you can see this is 2024. No, 220, sorry. So you can see the pattern of 220, and this is the pattern of 223. Now looking at the minimum and maximum value, there were, if you look at this, you see that there was higher rainfall and this have lower rainfall. So 2020 and 2011, from the data we have, 2011 have higher rainfall compared to 2020 within the study area or within the area we're interested in. But if we also look closely here, you see that this pattern here nearly form the same thing here, nearly form the same pattern, but somewhere here have another pattern. So this can be different kind of information. Like now, before there was no, in 2011 we were only using this, but in 2020 we have more point added to it, giving us more information about the rainfall. So this might be the factor, but also if you look at this pattern, you can also see changes that happen on it. So this is the way you can bring data as related to XYZ, whether it is elevation or it is rainfall or it is temperature or whichever data it is, and you can visualize them using this particular pattern.